Introduction to Statistics, Chapter 11, Inferences on Two Samples, Section 11.1, Inference about Two Population Proportions. Okay, first we're going to have to distinguish between independent and dependent sampling. A sampling method is independent when each individual selected for one sample does not dictate which individual is to be in the second sample. A sampling method is dependent when an individual selected to be in one sample is used to determine the individual in the second sample. Dependent samples are often referred to as matched pairs samples. It is possible for an individual to be matched against him or herself. This would be like a before and after. Requirements for running a hypothesis test regarding the difference between two population proportions. Most of what we do here in Chapter 11 is similar to what you did in Chapter 10, except for in Chapter 10 you were dealing with one sample. In Chapter 11 we're going to deal with two samples, but the basic idea is the same. It's similar. Okay, so 1, the samples are independently obtained using simple random sampling or through a completely randomized experiment with two levels of treatment. Second, if you take sample 1, n sub 1 times p hat sub 1 times 1 minus p hat sub 1 should be greater than or equal to 10. And sample 2, n sub 2 times p hat sub 2 times 1 minus p hat sub 2 is greater than or equal to 10. If you recall in Chapter 10, we only had one sample. So we took n times p hat times 1 minus p hat greater than or equal to 10. Now also from Chapter 10, we said the sample size had to be less than or equal to 5% of the population. So the same thing holds true here, but we have to do it for both samples. Sample 1, so n sub 1 is less than or equal to 5% of population 1. And n sub 2 is less than or equal to 5% of population size n2. This requirement ensures the independence necessary for a binomial experiment. Those are the three requirements for running a test regarding the difference between two population proportions. Now, hypothesis testing regarding the difference between two population proportions. We're going to do the classical approach. You will see that many of the steps we use here are similar to what we used in Chapter 10. We just have to modify a few of them. For example, determine the null or alternate hypothesis. In this case, if it's a left-tailed test, now we have two populations. So what we want to do is compare population 1 to population 2. So the null hypothesis will be that population 1, the proportion in population 1 is equal to the proportion in population 2. Remember, the null hypothesis always equals. So we have p sub 1 equals p sub 2. Or that could be p1 minus p sub 2 equals 0. If they're equal, you subtract them, you should get 0. Now the alternate hypothesis here, if it's a left-tailed test, that's going to be proportion 1 is less than proportion 2. Or, think about it, if proportion 1 is less than proportion 2, what about proportion 1 minus proportion 2? Won't that give you a negative number, which is less than 0? So, on the left is what is traditionally used for the hypothesis, the null and alternate. On the right is an alternate form, which is actually used in StatCrunch. That's why we're showing you the alternate. Now, a right-tailed test. Again, you would assume that should be p sub 1 equals p sub 2. Okay, that not should be a 2. Or p1 minus p2 equals 0. And the alternate would be p1 greater than p2, or p1 minus p2 greater than 0. Because think about it, if p1 is greater than p2, then p1 minus p2 is greater than 0. Two-tailed test, p1 equals p2, so then we would two-tailed p1 not equal to p2. Or we could write it p1 minus p2 equals 0, or p1 minus p2 not equal to 0. So these are the three new ways to write the null and alternate hypothesis. This is about, other than the formula to find the test statistic, this is the only change. Now step 2 remains the same. Select level of confidence alpha depending on the seriousness of making a type 1 error. And again, remember alpha is usually 1%, 5%, or 10%. But you could have a different. percentage. Step 3, compute the test statistic. Now, we have 2 samples, so this formula is going to be a little different and a little more complicated. So the test statistic Z naught is equal to p hat 1 minus p hat 2 divided by the square root of p hat times 1 minus p hat times the square root of 1 over n1 plus 1 over n2. And remember, p hat, in this case, we have 2 samples. So p hat's going to be x1 plus x2 divided by n1 plus n2. Okay, and again, StatCrunch will calculate the test statistic for you, so you will not need to use this formula. Now sketch the curve for the test. Well, the curve is going to be exactly the same as what we had in Chapter 10. Left-tailed test, you're going to have the left tail shaded. That'll be your critical region. That area will be alpha, and you'll have negative z sub alpha as your critical value. Right-tailed test, the right tail is shaded, critical region, z of alpha. And two-tailed test, you're going to have both tails shaded, and the area in each tail is going to be alpha divided by 2 because the total area has to be alpha. So this is the same as Chapter 10. Now, step 5, compare the test statistic with the critical value, see if the test statistic is in the critical region. This is the same as Chapter 10. Write a conclusion. This is similar to Chapter 10. You know, there is or is not enough evidence in the data at the 1, 5, 10, or whatever percent levels, and it suggests that, and then whatever the problem said. So basically, everything is very similar except for the null alternate hypothesis and how you would find the test statistic. The p-value approach, again, is very similar. Okay, the null alternate hypothesis, you know, left, right, and two-tailed test would be the same. Select level of confidence, alpha. Compute the test statistic. This is all the same as the classic approach. Now find a p-value. Test statistic using table or StatCrunch. Okay. Now when we run the hypothesis test on StatCrunch, you will be given the test statistic. You will be given the p-value. Okay. So you won't need to worry about using the formulas or the tables to find them. Left-tailed test, p-value is probability z is less than the test statistic, z naught. If it's a right-tailed test, the p-value is probability z is greater than z naught. And if it's a two-tailed test, it would be the p-value would equal 2 times the probability z is greater than the absolute value of z naught. And compare the test statistic p-value with alpha. Same as Chapter 10. If p-value is less than alpha, reject the null hypothesis. If p-value is greater than alpha, fail to reject the null hypothesis. Write a conclusion. Same conclusion, whether it's a classic or p-value approach. Is not enough evidence at the whatever percent level of significance to suggest that from the problem. Okay, so those are the classic and p-value for 2 population proportions. The only main difference is the null and alternate hypothesis and how you would calculate the test statistic. Now, using StatCrunch. This time you would open StatCrunch the same way you did in Chapter 10. But this time, you know, you're going to click Stat, top menu, highlight proportion stats, highlight to sample this time. Highlight to sample, click with summary or with data. Now, if I do with summary, okay, then you're going to enter the data for sample 1, which is the number of successes, x1, number of observations, n1. Fourth, enter the data for sample 2, number of successes, x2, number of observations, n2. Click circle beside hypothesis test for p1 minus p2. Enter 0 for p1 minus p2 value and choose correct inequality. Less than if it's a left-tailed test, greater than if it's a right-tailed test, not equal if it's a two-tailed test. And then click compute. Okay, we will run through a problem doing this. Let me end this here for a second and go to your homework. Let's see. Problem number 4 in the homework assignment. Here it is. Conduct the following test at the 5% level of significance by determining A, the null and alternate hypothesis, B, the test statistic, and C, the critical value. Assume that the samples were obtained independently using simple random sampling. Okay. Now, in this case, we want to run through, and if we run through this, we would have to first decide about the null hypothesis, alternate. Well, we always assume that P1 equals P2 for the null. So every one of these has P1 equals P2, so that's good. But what are we trying to show? It says test whether P1 not equal to P2, so that's easy enough. So that tells us we're going to do 2, the second one here. So we check it, that's okay. Now, the test statistic. So what we want to do is go into StatCrunch, excuse me, and run a test. Well, let me take and shrink this down, and let me pin it to the left side of my board. Okay, now, one of the problems students have is when you open up StatCrunch in these problems, StatCrunch opens up in the problem itself, and then you have to move it around, you can't see. Well, up here, if you click this little button here, this square with the arrow in, that'll take it outside of the screen. Okay, and then you can pin it to the right side. So now you have your question on the left side, StatCrunch on the right side. So if you recall, this is 2 proportions. So I'm going to hit Stat, Proportion Stats, 2 Sample, and I'm going to do with summary. So the number of successes for sample 1 was 28, because that's X1. Number of observations was 255. Oop, never mind, I got to cancel this. I only got 1. Proportion, 2 sample with summary. There it is. So sample 1 is 28 out of 255. Sample 2 was 36 out of 301. And I want to do a hypothesis test. I let P1 minus P2 equal 0, which is default. And this time I wanted to do not equal, so I'm already there. So click Compute. Okay, now my test statistic is right here, the Z-stat. The Z-stat is my test statistic. So how many decimal places? 2 decimal places, so that's going to be negative 0.36. Okay, and if I check my answer, we're good. Okay. Now, the next part, they wanted the critical values are plus or minus. Now it says round to 3 decimal places. Since this was a 2-tailed test, what we have to do is realize we're going to use the normal calculator. So you're going to go under calculators, normal. Okay, I want to find the area to the right of the critical value. So let's say alpha was 0.05. That's the total area. So if this is a 2-tailed test, we have to split that in half. So the area to the right, I want area to the right greater than or equal, is going to be half of 0.05, which is 0.025. Click Compute. So that's 1.96. If I round it, no, 3 decimal places. It's still going to be 960. So, and then over here would be the same, negative 1 point. So that's where the plus or minus comes in. So I'm going to put in here 1.960 because it asks for 3 decimal places. Check answer, we're good. Okay, and now test the null hypothesis. Choose the correct conclusion below. Well, if you look at this, okay, we could look over here. This would be a 2-tailed test. Now, let me check something here. If I would have done between, and I would have left this be 0.5. Now, that does not give me, that's the area between. Oh, so the area between, if 5% is on the outside, what's in between? That would be 95%, right? 0.95. There you go. So there's your negative 1.96, positive 1.96. Okay. So we could use the between also to get the critical values. If it's between, but you have to remember alpha is the area in the tails. If you're using between, you need the area between. So if 5% is outside, then 95% is between. So either way, you can do that to get the negative 1.96, 1.96. Now, to test the null hypothesis, we can use this graph right here. Take the test statistic, negative 0.36. Where would negative 0.36 be? Well, negative 3 would be somewhere in here, right? Which means it's in the red area, which would be the fail to reject. Because remember, you reject when you're out in the tails. So this would be in here, so do not reject. Okay, now, next question. This deals with a confidence interval, so we'll come back to it. So let's go back to our PowerPoint. And let's pick up the next thing, which is constructing a confidence interval. Requirements for constructing a confidence interval. Well, the samples are independently obtained using simple random sampling. You know, the same thing that we had for the hypothesis test. And also the sample sizes are less than 5% of the population. So everything is the same as what you would use for a hypothesis test for a confidence interval. Now, the confidence interval this time, remember in the past, chapter 10, it was p hat minus e, p hat plus e. But since we have two samples, it's p hat 1 minus p hat 2 minus e. And it's also p hat 1 minus p hat 2, that quantity plus e. And e would be equal to this formula. But again, remember, if you have the confidence interval, you can find e by finding the difference between the upper limit, lower limit, and dividing by 2. So the lower bound is p hat 1 minus p hat 2 minus e. Upper limit, p hat 1 minus p hat 2 plus e. Now, using StatCrunch. So, we open up StatCrunch the same way we've been doing. This time you highlight proportion stats, highlight to sample, click with summary or with data. And if we chose with summary, you would enter the number of successes for sample 1. For sample 2, enter successes, observations. Click the circle beside confidence interval for P1 minus P2. Enter level of confidence and click compute. Okay, so let's go back to the problem that we had in the homework, the next one we had. So if I go back to the homework, I have this. Now, if I open StatCrunch, move it outside, and pin it to the right. Okay, now I want a confidence interval. Now, if you read the problem, it says construct a confidence interval for P1 minus P2 at the given level of confidence. Okay, level of confidence is 99%. So down here in our problem, the researchers are, this would be your confidence, 99% confident. The difference between the two population proportions, P1 minus P2, is between. Now we have to go to StatCrunch to figure that out. So we go to StatCrunch, proportion, 2 samples, with summary. Now, so I enter X1, N1, so that's 33,242. And sample 2 would be 38,305. Click confidence interval, and I want a 99%, so I change this 0.95 to 0.99, and click compute. And over here is my lower limit and my upper limit. Lower limit, upper limit. So, how many decimals? 3 decimal places. So my lower limit would be negative 0.063. My upper limit would be 0.08687. 0.087. 3 decimal places. So I check my answer, we're good. And that took us through. So there's examples of using StatCrunch to get a confidence interval and to get a hypothesis test. So now, the next thing I'm going to do is using a confidence interval to determine the outcome for a two-tailed hypothesis test, trying to show that P1 and P2 are different. So we're testing the null hypothesis P1 equals P2 versus the alternate P1 not equal to P2. Well, if the confidence interval contains 0, once you get a confidence interval, if it contains 0, do not reject the null hypothesis. Okay? However, if the confidence interval does not contain 0, reject the null hypothesis and conclude that P1 is not equal to P2 at the level of significance. So that's how you would use a confidence interval to check a two-tailed test. Now, determining the sample size necessary for estimating the difference between two population proportions. If a prior estimates for P1 and P2 are known, P hat 1, P hat 2, so they're available. The sample size required to obtain a 1 minus alpha times 100% confidence interval with a margin of error E is given by. So N would equal N1, which would equal N2. So this would be for both samples. You know, the sample size would be the same for both. So it's going to be P hat 1 times 1 minus P hat 1 plus P hat 2 times 1 minus P hat 2 times Z sub alpha divided by 2, all divided by E, quantity squared. This is very similar to chapter 10, except for out here in front, you only had P hat times 1 minus P hat, because you only had one sample. Now we have two samples. Okay. Now be sure to round answer up to the next whole number in all cases. This has been something people have been emailing me about. You know, even if it comes out even if it would come out to 321, you would round it up to 322. If it comes out to 321.235, you would round it up to 322. Always round up to the next whole number, no matter what the number is. Now, if prior estimates for P1 and P2 are unavailable, we don't know anything. Now, if you remember in chapter 10, we used the 0.25 times the quantity. Well, in here, we're going to use 0.5. Now, the reason for using 0.5 is we have two samples. So the first sample would be 1/4, okay, and the second is 1/4. And you add those together, you get 2/4, which is 0.5, or 0.25 plus 0.25, if you look back at the formula in the previous slide. And again, be sure to round up to the next whole number. And this brings us to the end of 11.1.